Hey, Jason Scott here, and I want to give a huge amount of thanks to a young man named Jared Taylor. Okay, he followed my tutorial on my dirty elbow and knee pinning stretch, dirty stretch and elbow knee pinning thing. And basically, the theory is that you have a normal chain which is has all the IK system going, and then you have a whole nother bone chain, and you parent constrain the hip and the ankle, and then you orient constrain the bind to the IK, and then you have the IK and the pull vector point constrain the bind knee with no offset, which will make it jump to wherever the pull vector is, which basically creates a knee stretching effect. However, you will notice that when you do that, you're only working with the translation. You are not affecting the rotation on this hip or this ankle. So what actually ends up happening is this remains down here because it doesn't follow. So in order to fix this, we want to take this bind hip and make it follow either the knee to the pull vector, or we got to use a different setup. Okay, so what we're going to do for that is we're going to use an aim constraint. Now, as you know, aim constraints are very finicky. They're very picky and very specific. So if you have your leg built in a different direction or any of that, the values I'm going to tell you aren't going to work. So you're going to have to figure out, based on your understanding of aim constraints, how to position it correctly. Now, I'm hoping that you plug in the information and it works, but it could be some finagling. It actually took me a little bit of work to, get the correct values and find the right offsets and everything else. Okay, so first thing first, let's check, and we will see that the behavior is correct. Okay, notice that this all behaves just as you would want it to. Okay, it's all pretty much the same. You notice the Z's and the Y's are all pretty much doing the same thing. Okay, now, all right, this is Jason Schleifer's method, and you can tell by seeing that it's using a translate X. Okay, and it's using a input the elbow blend, which is the blend adder node. Okay, blend 2 adder node. And then you have no multiply divide or condition node setups. On the other hand, if we take a look at this knee here, it's using the scale X. And you see we have condition, distance, and multiply divide nodes, just as we do over here. Okay, condition, distance, multiply divide nodes using the scale X. So you can see the difference between this knee using the translate X and this knee using the scale X. This is a method that most people that don't use the Jason Schleifer method, a lot of people use the scale X to get their stretch. Pretty much, as you can see, it's the same results. Okay, completely different setup. Now, I did that to show you that I did fix my problem. This is my system fixed, so we can see what it looks like. Okay, this is elbow pinning, correct elbow pinning. All right, let's test it out. I want you guys to watch and see the Y's. They jump up at the exact same time, exact same position. The Z's jump up, and we're good to go. Knee is pinned. All right. We pull down. Notice the knee does not move. Okay, knee is pinned. Same behavior. Knee is pinned. Good to go. All right. Now, so now that we know that we fixed it, let's take a look at the problem. Alright, we will take this, go back, and now we will select both of these objects. Okay, and we will stretch. Now I want you to look at the Y's. Focus on the Y's. See how this Y moves up and this doesn't? Okay, this is not following. So to fix this, what we're going to do is we're going to take this object, we're going to select the actually, let me talk about this first. In my tutorial, I actually used this main object and had it parent constrained to here. Instead, what you want to do is group it, and then the actual group is what's parent constrained to the left hip bone. All right, because we want to leave our orients free, so that, or our orientation and rotations free, so that we can aim constrain. Okay, so keep that in mind. All right, so we have the knee, we have the pull vector, and we're going to grab this object, constrain, aim. All right. We're going to use an offset of 0.484. Aim vector is 1 in the X. Up vector is 1 in the Y. World up vector is 1 in the Z. I'll let you take one quick look at this. Alright, so you can see my values. Don't worry about the offset. That's going to vary depending on what you're doing. offset aim vector is 1, up vector is 1 in the y, and world depth vector is 1 in the z. Alright, hit apply, and you will notice that we get a nice clean blend. If what happens when you do this is it shoots up over here, or curls, or shoots off to the back, you know you did something wrong. Okay, so to fix this and test it, we can then turn off the knee so that it just goes to the locator. Okay, and notice that it gives us exactly what we want. That's what we want. Alright, now we're going to take the pull vector, and then we're going to take the ankle and select this object and hit constraint. Actually, we're just going to go here to where we were before. Same thing, we're going to zero out our offsets. Okay, aim is 1 in the x, up vector is 1 in the y, world up vector is -1. Okay, in the z. Apply. Okay, close. And you'll notice that we get exactly what we want. Now, if we turn the locator off, alright, we're good to go. So now you'll notice that our behavior is correct. It's pinned, it's locked in place, and if we select this object, and we actually grab the thing here, parent it so that it follows, okay, now you'll notice that, okay, the knee is not moving, and the knee is not moving. The knee is pinned in place. This is correct knee pinning. So we fixed it. But what happens now when we go to stretch? Okay. Uh-oh, that's not what we want. So what we now have to do is take this object, hit F. Okay, let's find our aim constraint, and animate, set driven key sets, load driven, grab this object here. Okay, for the sake of what we're doing, for the sake of speed, we're going to go here, key, no, load driver, here, stretch, all right, key, turn this to 0, and just reverse it. This is 1, this is 0, hit key, and now you will notice that when it's stretched, it's elbow locked correctly, okay, just as we want. And you can also notice that all the values and orientations are all correct. As you see, my local rotation axis shows all the x's are going down. Alright, so let's check that out. Okay, all the y's are like a little army of y's. They all shoot up. All the x's point down. All the x's point down. Okay? The z's are where the z's are supposed to be. And everything works just as it should. Okay? And there is your knee pinning. Okay. Alright, cool. So, having fixed this now, does it still work? Yes, it does. Okay, it still follows this object. So we still get correct IK positioning. So, that is a solid fix. Not only does our local rotation axis now match with a solid scripted Jason Schleifer method, but in addition, we can see that the behavior is correct, and there are no blend adder nodes. If we take a look at this here, we go to Windows, Journal Editors, actually Hypergraph Connections, I believe. Graph, Input and Output Connections. You will notice, let's see, where's the stupid thing? Actually, no, we gotta do the start. Graph, Input and Output Connections. Ugh. There, okay. Let's see, where's this stupid thing? Distance, transform. Here it is. Okay, blend 2 adders. See, the blend 2 adders. So you got their animation plugging into that blend 2 adder, which plugs into the translate on the okay. On the other hand, if we select this here, and we go to Windows, Hypergraph Connections, you will instead notice a completely different setup using a bunch of constraints as well as, let's see, a condition node, multiply divide node. It's a completely different system, completely different setup, and our behavior is working correctly. Okay? So, that is the fix for when you run into that S-shaped thing. Okay? You're basically just going to have it so that the bone is aim constrained between the knee and here, and you want this aim constrained to this one. Okay? And then as long as you do that, you're good to go. Alright. thank you guys for your input. I really appreciate it. Please continue to test out my stuff, and if you find problems, let me know, because now that this is troubleshooted, the next time I go to implement it myself, or I suggest someone else to work on it, they'll be able to make it work, and we'll be able to add more to the community overall. Thank you very much. You guys have a great night.